Great. Yes, I would like to say thank you for also being invited, having me. And I think what I'm going to talk about is quite different from what we just heard. We are not looking at a problem very centralized. We are looking at a huge problem, but which we don't know so much about. But yeah, in theory, actually, how to optimize the energy consumption in a nation, a whole nation like Denmark, for instance. So, what we were setting out to do is switch to the next slide. Here we go. Maybe. Here we go. Yes. So what we were set out to try to do was to see if we optimizing all the sub problems in a huge problem might not be the solution overall. So trying to see if we could look at the bigger problem and then try and slice it up in smaller bits and then solve it from the top down instead of from the bottom up. As we all know, if we are looking at our households, we are trying to optimize the energy consumption within our own houses. And by doing so, we might come up with a solution that could optimize the utilization of energy and everything which is very important at the time being. And then everything is good, you might think. The problem is that if everyone was behaving the same way, it might produce a larger problem, which means that, for instance, if you turn down the heat during the night, then if everyone in the morning turns on the heat, you might create this problem that the need for heat in that kind of amount, it will have to what you call, you will have to start an extra what I don't know what the English word actually for another. In a city, for instance, you have different plants producing energy, and some of them are dormant when they are not being needed, but then they will have to start them up because they need to meet the amount of energy needed, and that is very expensive, and it could also be very energy inefficient because you're going to lose a lot of energy while producing, having it up and running. So what we're trying to do was, this is a very quick elaboration of what I told you in a previous session, and I believe that the recording from last time can be found on the website. So I will not go so much into detail, but very quickly just saying that we're looking at the buildings overall in the entire country, like Denmark, because we have a lot of data on every building in all of the country. So that is one thing. Then we are having this energy key systems, which I'm representing for KMD, which is in almost or in a lot of homes in Denmark, and it's collecting the meter data from these buildings, and we have an energy management system, EMS system, that is correcting all the data and actually making some output that can give back to the system. So what we have here is that if we had all the buildings, all the measurements, we somehow would have some information about a lot of buildings, and if we could categorize those, saying that there will maybe exist 50 or 60 different types of, last time I called them digital cousins and digital uncles because I didn't know what else to call it. It means that I don't know 100% one building, but I know a lot of buildings which are quite similar. And if I at the same time have current real-time information about what's going on in these buildings, I might be able to calibrate the model and then see if they are actually in the same category. And what the aim is that when we have established some kind of a model which is coherent, then you will be able to say, okay, if something is done in one representative in one category, and you can measure what is going on in that one particular building, there is a good chance that this better behavior or optimization would be something that could be used for the entire population within that category. and that could be eventually tested and then recalibrated to see if the result was as expected. So, for instance, in Denmark, we have 2.25 million buildings all in all, which is divided into these different types of buildings. I'll not elaborate, but as you can see at the bottom, right at the bottom, 1.1 million buildings are housing. So there's quite a lot of buildings to look at. And at the bottom, many of those are very quite similar. So there might be a potential to look at here. And in order to understand the data we're working with, I haven't made this particularly for this presentation, but I've been doing it because I needed somehow to visualize and show people what kind of data and the amount of data that we're working with. So what I'm showing you here is the different tables and different data rows and the size of those within that data set, which contains information about all the buildings. So this is authoritative data on every building in the entire country. And this reddish globe here is showing the size of the entire data set. And the blue one, that is including history. So if, let's say we would have 10 years, it would be one size, 20 years, even larger. And then combining this data with a lot of other basic data that we have in Denmark regarding addresses, parcels, and infrastructure, and a lot of other interesting or data in this regard, then we will have a lot to work with. So that's our basic, what we're starting out with. So what I didn't talked about last time was this. We also have another register, another database full of data explaining or describing the energy efficiency of every building. We have in Denmark what we call energy labels. So every building in Denmark has been examined and has been given a label from A to G, where A is the best and G is not so good, and describing the energy and efficiency. And how is that done? That is done actually by having a certified person, a real human being, to come to this building and have a look at it and look it through and see what is how big are the windows, or what kind of, how old are they, the insulation and the roof and everything. They look through, and they have to list also all the improvements that could be made, and giving an estimate of how much that would help that building to become more energy efficient. So having this data as well as the before mentioned data, we believe that it would be possible to look at the population and see that all the G's and F's and E's, are those the ones that we should look at, or are we going to look at the other ones and then comparing it with the real-time data from the energy key system? So the energy key is, as I said before, collecting a lot of IoT data from meter measurements around the country, and it's been centralized and put into the system. And what we would like to do is that, as I said, we have some knowledge at the bottom. We have, that's the basic data. We have some assessments data, which could say something about the capabilities of the buildings, as I said, all these humans going around to see if they, and I forgot to say that is something that should happen at least every 5 years, or every time a building has been sold from one person to another. So it is not happening very frequently, but it is happening. Then in the middle, we have the consumption data. And on top of that, we would like to start predicting the consumption based on the information we have below. Then we would define and identify problems that we would try to solve. And then eventually at the end, start using digital twin methodology or disciplines in order to try and understand and see if we can how do you say, improve on the system and improve, see where something could happen. And I think, or I mean, Right now, it's very static data, which is being collected. It's only the energy consumption data, which is real life. But what we would like to do is this. So this is a very busy slide, but if you start right at the top left, then you see there is a partner which we're cooperating with, which is called Energy Systems. They are collecting the energy label data from the energy agency, which is at the bottom left. So the energy agency is the register owner, the owner of the data for the entire country for these energy labels. They are taken up to the energy projects in energy systems, created into a common data model, which is shared with KMD. And these data are actually being distributed to the municipalities in Denmark. And who are actually those who we believe could benefit from this project first? We believe it's the municipalities because they are the authorities having a size which is big and but also have the responsibility of trying to make the cities more energy efficient overall. So what we're doing is that we are distributing the same data, much of what I've just shown, and maybe more, and giving access to the data, which is, we have something called KMD access and insights data, which is business intelligence modules and so forth, but also an integration to the Energy Key EMS system, which is the one in the municipalities could monitor what is actually going on. This is fed back into the energy projects, and there we are trying to do something elaborating or elevating the information we have in the data, because based on the models for energy labeling, we are recalculating the energy label dynamically as often as we can. So that means instead of having 5 years between every energy label, we can produce it daily, for instance. Meaning that if a building has changed some properties, because during 5 years you might do some enhancements on the building, build a new room or kitchen or bathroom or whatever, and this information should be considered, and we can see that from the data we have in the BBR, which was the globes that I just shown, which contains that kind of information, combined with the real-time data, which says exactly what is going on right now, and then having these energy label, which was something as an assessment made by a certified person at some time in time. Then we can recalculate the energy label, and then the what you call it, the circle is full, and we can having continuous. But in the center, and that's where we are at the moment, but we haven't really getting started to that yet. But in the middle, we have some kind of a data prediction, digital cousin component, which will be it's such a huge amount of data that we will need some kind of an AI or a lot of resources in order to monitor and calculate on this data and follow up and identify patterns in the energy consumption. We have an AI department in KMD. We would like to involve those guys. We are not there yet. We are working closely with energy systems in order to get the automated energy label component working, so that we can actually start on using the live data from the Energy Key. And in order to, we believe that even though we haven't done this yet, we are believing that in order to make this efficient, we will have to make the data more real time. I mean, and that means that all the information that we gather from the IoT devices, it will take too long to get it through Energy Key, EMS, and energy systems. We would like that to come into an open platform like Fireware, if you might have heard about, but it is a standardized open source platform that collects IoT data is really good at standardizing IoT data from numerous different types of IoT devices. And what makes value here is that in the middle of that, there is what they call a context broker, which is where we could place all the basic data and the information about the buildings and so forth, so that information coming at one moment from a given IoT device, it can put itself into a context and generate some events, which will then be subscribed from other components, and those things that we would like to happen couldn't then happen if they are monitoring certain kinds of events. So that's a further step, but as I said, let's do the first step before we do this. But we have the technology together with NEC, which is our owner. So if we should succeed, we already more or less have the next step put together. So that's the status right now. It's very much a concept still, but we hope if we could get some of those AI guys working with us or somebody else, a partner or something, then we could actually start to get some, try to get some result and see if this is even possible. So that concludes my presentation for this time regarding the energy key system and the ecosystem around it. So thank you for listening, and maybe there are some questions.
Thank you, Sik. You have some very special challenges with like all that public data, and especially considering the huge amount that you're dealing with. So yeah, are you more looking into data mining, like the application of data mining, or is this going to be more for building models and using digital twin approaches?
We are in a situation that in Denmark, we actually have a lot of this basic data. We've been collecting it for many years, so we have a good tradition of having everything categorized or having it in data, and therefore we have this huge amount of data. What we're trying to do here is actually trying to see, can we get some value out of this existing data? They were produced in a time where energy, as we mentioned before, wasn't an issue, not so much as it is now. But with this data and with new data that we could, and data mining could, of course, be a possibility as well. We would like to see, can we get started on having some overall models running that could identify what is actually going on in the huge perspective. Very ambitious, I know, but maybe we should. I mean, we're talking about smart cities. We have been talking to each other and say, what about a smart village or just a smaller thing, and then we can start from there.
I'm still trying to put it into context with what we are working with in the industry, for example. But I think the main difference here is that...
Yeah, I understand.
That,
it could be hard because it's so far from... yes, I know.
And that there's so many actors involved. It's not just one actor, which is the company or like the process, but you have many actors, all the people owning the buildings. And so if you have to work with all of them.
But then again, this is something that because the municipalities, they have the authority within the city, and those producing, for instance, energy and heat are the companies that they have a business relation with all the owners of the building. And it could be that if let's say that a legislation or something would put in effect this kind of data, not a particular kind of data, because we need to anonymize the data, but we could say that, or it could be something that we could get access to in aggregated data form, and then the data is there. That's just what I'm saying, and we just need to get the process of having those data available.
Are there any other questions? All right, then thank you again, Sik, for your presentation. I'm looking forward to hear about whatever you managed to do for like in a year or so.
I think the next steps are going to be the crucial ones to see, because as I said, a concept that's easy to make, but actually getting it to work is just another matter. Yeah.
Well, best of luck.
Thank you. Thank you.